Welcome back everyone. This video is going to be discussing the architecture and installation path of Splunk, as well as how that directory is laid out from both a Windows and Linux perspective. I have both open right now. On my Windows side, I've got it installed to C program files Splunk, which is the default directory. On the Unix side, I have it installed into the opt directory. Both of these can be changed if you want, but these are the defaults. We're going to discuss the components of Splunk. So the main component is the full install. And that full install is really just this program. Now when we install a full version of Splunk, it comes with the web UI. What you're going to be used to seeing from a user perspective. You've got your login, and then once you've logged in, you've got your main apps, as well as your search, which is what we were using before. It's important to understand that what you're seeing here is really just what's happening here in the back end. It's not magic, it's a bunch of configuration files and scripts that run the front end for you. As a front-end user, you might not care, but as an admin, it's extremely important to understand anything we do on the back end is going to affect the front end, and vice versa. So if we use our settings page to change any sort of configuration, it's going to write to the back end. So now we need to talk about how a full instance of Splunk actually ingests and searches data. We know I have my log file, my cool log file.txt, and I ingested it into Splunk, and then I searched it. This is all happening on my single instance, which is my home computer at this point. What happens if I have lots of data, lots of log files coming in, and it's more than my system can handle while doing search? At that point, we do something called distributed search, and we distribute the component that actually ingests data into its own instance, another machine. And we call this an indexer. And then do only our searching on the original instance, and we call that a search head. And now all of a sudden, we're searching from the search head and indexing, pulling in data to the indexer. And we've distributed the load across two systems. Eventually, we're going to ingest even more data, and to handle that load, we need to add more indexers. This is called horizontal scaling. As users begin to search more and create reports and alerts, we need more resources at the search head tier. So we begin adding additional search heads and put it in something called a cluster. And a cluster is really just a way to make the search heads aware of each other so that they know whose resources to use to execute the search. Now that the search heads are in a cluster with each other, anytime a user makes a report, alert, dashboard, any sort of knowledge object, they're going to be replicated across the cluster to each search head to make them consistent. However, that only works with the front end. To make back-end configuration changes, we can no longer just log into a search head and change the configuration file in the back end, because it will make it inconsistent with the other search heads. So now we need another server. We call this server the deployer, and its whole job is to push configurations to the back end of a search head and distribute it across the search head cluster. Now that we're talking about clustering, we need to go back to the indexer tier for just a second. Because we have 3 indexers, our data is actually being split 3 ways. So if an indexer goes down, we lose a third of our data. The best way to mitigate this problem is to put the indexers into a cluster. This way, when data comes in, it is replicated to another indexer. And this process continues so that even if we have an indexer go down, we still have copies on the other indexers. Just as the search head cluster has a dedicated server called a deployer to push and manage configurations, the indexer tier has a dedicated server as well called the cluster master. It additionally has the job of managing the bucket replication. So let's talk about the component that actually sends the data. This component is called the forwarder. It's basically a lightweight version of a full instance of Splunk. It doesn't have a web UI. We install the forwarder on basically all endpoints: Windows and Linux servers, workstations, laptops, tablet. We do this because it allows us to monitor log files, ingest WinEvent log and var log, as well as pull performance metrics from the system. Once again, we need to centrally manage the configurations for the forwarder layer, so we're going to add another server called the deployment server. But unlike the cluster master and the deployer, this is not a push, it is in fact a pull. Every 60 seconds by default, a forwarder will call into the deployment server and check to see if any new configurations are available to it. One note about the deployment server: if you do not have an indexer or search head cluster, you should configure those tiers to talk to the deployment server and pull down configurations for central configuration management. Putting our search heads and indexers into a cluster achieves what we call high availability. Essentially, even if an indexer or search head goes down, we have other search heads and indexers to utilize, and therefore they are still available. However, high availability does not protect us against disaster scenarios, such as an earthquake at the data center. For that, we need multi-site clustering. Essentially, we copy all components from one site over to the other and replicate between both of them.